My dear students, in the previous video, we have completed the topic, chapter 6, linear inequalities. I have solved all the exercise problems in the chapter 6, linear inequalities. And in this video, I am going to start the new topic, chapter number 13, limits and derivatives. Limits and derivatives is the area comes under the chapter calculus. The calculus is a vital area in mathematics. See, calculus is very useful area in mathematics. Calculus consisting of limits, derivatives, that means differentiation and integration, applications of differentiation, applications of integration, and differential equations, like that. The topic covers the calculus topic is a very vital topic, and it is used in many mathematical areas, not only in mathematical areas, it is in science and technology areas also developed by the chapter calculus. Calculus is nothing but rate of change. The fundamental idea of calculus is rate of change. That means the derivative of the function y with respect to the function x, that is the rate of change of y with respect to x, is main definition of a derivative. So rate of change in mathematics is nothing but the rate of change of a line describing various slopes. Like that, the rate of change in physics expressed as rate of change of displacement and rate of change of velocity and so on. Similarly, in chemistry, the rate of change of a chemical reaction is determined. The rate of change, the word rate of change in chemistry is rate of change of a chemical reaction. And as well as in economics, the rate of change of the growth of the population of a country, or rate of change of growth of economic growth, that means financial growth. Like that, this calculus topic is used in mathematics, physics, chemistry, economics, and business mathematics, statistics, and so on. So like that, it is a very important area, and in that area, our topic is 13th topic, limits and derivatives, and that is also first I am going to give the definition limits. We will see the limits, limit of a function. First we are going to see limit of a function. Y equal to f of x is a given function. Y equal to f of x is a function in x. Function in x. In this, x is a independent variable and y is the dependent variable. X takes the values independently. X is the independent variable and y is the dependent variable. The y changes its values according to the values of x. X attains the values automatically. This is an independent variable. According to the value of x, y changes its value, therefore y depends upon the value of x. Y is a dependent variable. See, when x approaches to a, the value of the function, f of x is L. As x approaches to a, the value of the function f of x is L. It is defined by limit x tends to a, f of x equal to L. This is the definition of a limit. Limit x tends to a, you read it as x tends to a, or x approaches to a. The function value of f of x is L. This is the limiting value of the function f of x when x approaches to a. In an interval, suppose this is an open interval. In this interval there is a constant a. If x approaches to a, the function is defined on this interval x approaches to a. The function f of x is an interval defined by L. This is the limit of the function f of x when x approaches to a. The value of the function is L. This is the definition of a general definition of the limit of the function. For example, limit x tends to 5 f of x is equal to, where f of x is, you consider the f of x by x plus 5. So f of x is limit x tends to 5, f of x is x plus 5, that is equal to, x is 5 and x approaches to 5, it is 5 plus 5. So answer, the limiting value of the function is 10. Limit x tends to f of x is 10, where 10 is a constant, here is the L is a constant. Like that, the limit of a function is explained. Now, I am going to define two different limits. Suppose x approaches to a from left to a, and similarly x approaches to a from right to a. These two different limits are we are going to define now. If a limit of a function f of x and x approaches to a from left side to a, it is called a left hand limit. And similarly, if the function f of x as x approaches to a from right side of the interval, x tends to a from right side of the interval is denoted by a right hand limit of the function. We will see that definition one by one. This is the general definition, limit of the function. Now, two types of limits of the function we are going to see now. First, left hand limit. Left hand limit of a function. Suppose f of x is a function defined and an interval y equal to f of x is a function defined on an interval I. This interval is denoted by I, and we are going to find out the limit of the function f of x as x approaches to a. X approaches to a from left side of the constant a, or x takes the values less than a. That is, y equal to f of x is a function defined on interval I, defined on an interval I. In this interval, in that interval, we have to find out the limit of the function f of x from x approaches to a from left side. In that interval, x approaches to a from the left of a. In that interval, x approaches to a from the left of a, that is, x attains the values less than a. X attains the values less than a. interval x approaches to a from the left of a, that is x attains the values less than a from this side, is denoted by limit x tends to a minus limit x tends to a minus, you have to read it as limit x tends to a minus f of x, it is equal to some constant L. Limit x tends to a minus f of x is the value of the function L. X approaches to a from left side to a, that is x attains the values less than a. Similarly, in the interval x approaches to, if x approaches to a from the right of a, from the right side, from the right of the constant a, that is x attains the values greater than a. So in this that x approaches to a in the right side of a, that is x attains the values greater than a. X attains the values greater than a. It is denoted by limit x tends to a plus f of x. This is also equal to f. The function value is also equal to f. This is left hand limit, and this is right hand limit. Right hand limit is if x approaches to a from the right of a, that is x attains the values greater than a, is denoted by limit x tends to a plus f of x. That's also a. That's also L. So left limit should be always equal to the right limit. Then only the limit exists. That is the major condition. If the left limit should be equal to the right limit, then only the general limit exists. So that is, we have seen that left limit of the function x f of x and right limit of the function f of x. Okay. Next. Generally, if limit x tends to a minus f of x should be equal to limit x tends to a plus f of x, both are equal, then only we can say that the limit x tends to a f of x, that is equal to L. All the three values, limit x tends to a minus f of x is L, and limit x tends to a plus f of x is L. Therefore, the limit value of x tends to f of x is L. If the left and right limit should be equal, then only the limiting value is exist. If limit x tends to a minus f of x is not equal to limit x tends to a plus, if limit x tends to a minus f of x is not equal to limit x tends to a plus f of x, then limit x tends to If it is so, then x tends to a, limit x tends to a, f of x does not exist. If it is the case, if it is not equal, does not exist. If the left limit should not be equal to the right limit, then the limit does not exist. If the left limit should be equal to the right limit, then only the limit exists. This is the condition. And we will see one example. If f of x equal to x plus 10, limit x tends to 5 minus f of x is equal to, it's also 5 minus is approaches to 5, that is equal to 15. Similarly, limit x tends to 5 plus f of x is also 5 plus 10 is equal to 15. Both are equal. Therefore, limit x tends to 5, f of x is x plus 10. F of x is 5 plus 10. Similarly, limit x tends to 5, x plus 10 is equal to 5 plus 10, that is equal to 15, exists. These two are equal. Therefore, the limit x tends to 5 f of x plus 10 is exist. Okay, this is for the left and right limit are equal. One more case we will see. Next example, consider the function if f of x equal to 1, if x is less than or equal to 0, 2, if x is greater than 0. Consider this function. If it is the case, this is x-axis and y-axis, origin. This is 1 and this is 2. Limit x tends to 0. Find limit x tends to 0 f of x. That is our problem. First, left limit we will see. Limit x tends to 0 minus f of x is limit x tends to 0 minus limit x tends to 0 minus less than 0 is 1. F of x is 1. Limit x tends to 0 less than or equal to 0 is 1. Therefore, limit x tends to 0 minus f of x is 1. Similarly, limit x tends to 0 plus f of x is equal to limit x tends to 0 plus f of x. Again, 0 plus is greater than 0. Greater than 0 is 2. That is, this is the value. Left limit is 1 included and this is the value. Right limit 2 excluded because greater than 2, they are not equal. Therefore, this is right limit. Therefore, left limit should not be equal to right limit. Therefore, this limit does not exist. Therefore, limit x tends to 0 minus f of x is not equal to limit x tends to 0 plus f of x because this is 1 and this is 2. Therefore, not equal. Therefore, limit x tends to 0 f of x does not exist. That is the problem. Does not exist. That is the problem. Okay? That's all about the problem. One example, previous example, we will see that the both limits are exist, therefore limit exists. In this example, left and right limit are not equal, therefore the limit does not exist. Okay, and we will start the exercise problems in the next video. Thank you.